Hello! Today we are going to be looking at chemical names and formulas. So we've been talking about all kinds of these. We're just going to put all the pieces together now. So we know that we've learned how to do acids and base naming. We've learned about ionic. We've learned about covalent. So really the big piece is to think about what kind is it and then name it according to those rules. So, does it have acid in the name? Well, then we know it's going to start with H+. H+ is going to be your cation, and you're going to balance out your charges, doing your crisscross and reducing. Does it have prefixes? If it has prefixes, you know it's going to be covalent, and so don't do anything with it, just use the prefixes. They're going to tell you how many of each atom, that's it. Does it have a metal and a nonmetal, or a cation and an anion? Well, then you're going to do the charges and reduce and crisscross in order to get your formula. And watch out those transition metals, the ones in the middle. Remember the Roman numeral is the positive charge. Same idea. Does it have a positive and a negative? So sometimes you have like the ammonium is all nonmetals, but it's still a cation. So use the back of that periodic table to help you with that. Be careful of those, but that's ionic. So here's a couple to practice. Give it a try. Got it? Yeah, so BaCl2, first thing we're going to recognize, barium is a nonmetal. Sorry, barium's a metal and chlorine is a nonmetal, and so we're going to have BaCl2, and so barium's a 2+, chlorine's a 1-. The crisscross, we don't need a Roman numeral because barium is always a 2+. It's in group 2, and so we can just put barium chloride. For N2O3, that's 2 nonmetals, so that's going to be covalent. We're going to use prefixes. That's dinitrogen trioxide. FeCO3, Fe is a metal, and so this is an ionic one. It's a metal that's a transition metal, and so we need a Roman numeral. So iron is our metal. CO3 is our nonmetal. Since CO3 is a 2- ion, and there's one of the group, that means that there's 2 electrons being received total, which means the one atom of iron has to be giving 2 electrons away. So it's iron 2 carbonate. Next one starts with H, and so that's going to be an acid. The anion is sulfate, and so I ate too much. Sulfuric acid is the name that goes with the ic ending, goes with 8. And then we've got CuO. Copper is a metal. Oxygen's a nonmetal, so it's ionic. Oxygen again is a 2-, which means the atom of copper must give away 2 electrons, so it's copper 2 oxide. All right. How about a few more? Give these a try. All right, here we go. So chlorous acid. Acid, so it's going to start with H. Chlorous, us, might be a mouse in the house kind of thing. Aus goes with the ite, might be a mouse. So ite, so we're looking for chlorite, and that's ClO2. So H+ and ClO2. ClO2 is a 1-, so we only need 1 hydrogen. Chromium 3 fluoride. So chromium is a 3+ because of the Roman numeral 3. Fluoride's a 1-, so we crisscross that. Magnesium nitrate. Mg is a 2+. Nitrate, make sure you look that up on the back of your periodic table, is NO3. That's a 1-, so the 2 and the 1. 1 magnesium with 2 groups of nitrate. Ammonium, that's the NH4 1+, and chloride is a 1-, 1+, 1-, 1 of each. So 1 set of NH4 and 1 Cl. All set. And carbon tetrabromide, that is 1 carbon and 4 bromides. That's covalent because there's prefixes. So don't do any crisscrossing or anything, just do what they say. All right, so what we're going to have you do is make a flow chart And that flowchart is going to help you to know just exactly what to do, and then you can use it to help you think about, okay, what rules do I follow? So your flowchart, you're going to really kind of ask a question and then find your way, like depending on the answer, go to a different spot. And then ask another question from that spot, and depending on the answer, go somewhere else. Let me give you an example of what a flowchart looks like. So this is a flowchart. It's not a flowchart for naming, which is what you're going to do. This is a flowchart for what intermolecular forces are present, which we learned about in previous chapter. So on this one, we asked, are ions present? And if yes, then we went over to this question. And if yes, then we said, are polar molecules present? And if no, then we said, oh, it's ionic bonding is what kind of forces are there. If yes, then this happened. So same kind of thing you're going to do is where you're going to ask a question in a box, and then depending on the answer, you're going to go to another box. I'll give you a hint. Where do we want to start? Well, you want to think about what kind of substance it is. So I would start with the question, is there metals, nonmetals, all nonmetals? Are there metals present would be a good question to get started with. So things we want to have ionic compounds. Remember to think that they're binary, and there's the polyatomic kind of ones, and some special cases. There's molecular or covalent compounds. We want that to be kind of an ending point to tell you what to do if you have covalent. And then we have acids, and you want to think about the acids that are in there too. So make yourself a flowchart that you can follow as you think, okay, is this ionic? Is it covalent? Do I use acid rules? Do I kind of questions that you can follow as you go. Some possible starting questions like, is there a metal? Does it start with hydrogen? Those are good questions to have. Does the name have the word acid in it? Those are good places kind of to start. So, and you're going to submit this flowchart as part of your assignment today. All right, good luck. Have a great day.